Thank you.
This is for the...
Oh, I see, for the slide. Okay, yes. Yeah, well, thank you so much for the kind introduction. So the thing that I wanted to talk about is simple roadmap for layer 2 scaling and security, right? So scaling, a really big topic on all of our minds. So I think in the last couple of years, we've been going through this really important transition from Ethereum just being this kind of very mostly theoretical thing that relatively few people are using, but lots of people are making a lot of really cool experiments on, to Ethereum being something that supports like very big mainstream applications that are being used by millions of people, right? And I think it's always important to remember that like really Ethereum is being quietly used by a pretty huge number of people today. There's a huge number of people who use it for international remittances. There's a huge number of people that just use it for payments and savings. There's huge numbers of people participating in DeFi. A lot of people using things like prediction markets. A lot of people using things like Farcaster. WorldCoin got to 10 million users. So a lot of things are actually getting pretty significant in terms of scale. And there's a lot of projects in the pipeline that wants to get to a much bigger level of scale, right? Like there are projects that are willing to get to a much, much higher level of users as long as there is space for that. And so to make sure that there is space for everyone who wants to be on Ethereum to actually be able to be on Ethereum, Ethereum needs to scale. And while Ethereum scales, one thing that is really important is we do not want to compromise the fundamental properties that make Ethereum be Ethereum, right? We do not want to compromise on permissionlessness. We do not want to compromise on Ethereum being a global, neutral, trustless, open platform. We do not want to compromise on censorship resistance, and we do not want to compromise on security, right? We do not want to accidentally move back from being an ecosystem where people actually can have guarantees that the assets that they're using actually belong to them into an ecosystem where like everyone is trusting very small multisigs, right? And so scaling and security are really important things that we really need to keep in mind and solve for at the same time. Now, scaling has a layer 1 side to it, and it also has a layer 2 side to it. And both the layer 1 side and the layer 2 side are important, right? And about a month ago, I wrote this article where basically I talked about how there's actually value in increasing the L1 gas limit by something like 5 to 10x, even if you believe that basically all applications are going to be on layer 2, right? So the value of the Ethereum layer 1, at the very least, as this kind of central coordinating point, as a point through which cross-layer 2 interoperability happens, as a point through which Ethereum users go when they're moving between layer 2s, all of these use cases, it still requires L1 to scale, right? So L1 scaling is important, but L2 scaling is also important. And L2 scaling, I think, actually can happen quite quickly, right? So this is the really nice thing that I think is really important to keep in mind, right? Which is that, like, it's taken us a very long time to get to where we are today, but we've actually built a huge amount of technology in the last 5 years. We have tools today that we did not imagine that we would have at all 5 years ago, right? And a lot of the existing layer 2s, Optimism, Arbitrum, zk-Sync, Ink, Starknet, all of these, a lot of them, they're actually using these technologies under the hood. But if you really start to combine the technologies together, you realize that like actually we are in a position where we can scale quite quickly, and we can do so in a way that actually does quite a good job of preserving security. So, step 1, scaling the blobs, right? So last year, in Ethereum, we had the EIP 4844 upgrade, which introduced this concept of blobs. So it introduced this concept of having this separate data space where layer 2s could have their own transactions. And this greatly increased the scalability of layer 2s. It decreased the cost of layer 2s by a factor of about 50. And it basically really kickstarted the layer 2 ecosystem as it exists today, right? But blobs as they existed as last year, like that, and as they exist right now, they're only the first step in the Ethereum layer 2 scaling journey, right? So the hard fork that is currently tentatively scheduled for the end of April is going to increase the target number of blobs from 3 to 6 and increase the maximum from 6 to 9. So what does increasing the target from 3 to 6 mean? It means that the data space in Ethereum blocks that layer 2s can use to put their transaction data goes up from 375 kilobytes to about 750 kilobytes. Now, how much does 375 kilobytes give you, right? 375 kilobytes, if you divide by, say, about 150 bytes per transaction, then you basically get about 2,500 transactions in a block, divide by 12, and you have a little bit more than 200 transactions per second, right? Now, in Pectra, going up from 3 to 6, and so we go up from about 200 transactions per second on layer 2s to about 400 transactions per second on layer 2s. And then at the same time, there's a lot of things that layer 2s can do to improve their efficiency, but really the biggest gains happen after, right? And so in Fusaka, the plan is to introduce this upgrade called PeerDAS, right? And PeerDAS basically means instead of requiring every node in the Ethereum network to fully store all of the blob contents, we actually start sharding the data, right? We actually start splitting it up, and we start only requiring each node to store a small portion of all of the blob data. And by doing that, we can greatly increase total scalability. So the hope is to get to 48 blobs. There's actually a couple of different proposals. One of them is to get to 48 at the end of this year. Another is to get to 12 or 24 in Q3, and then increase very quickly after that. So there's a couple of different proposals, but in all of the cases, the goal is to pretty quickly increase the blob count. And then if you do that, then the number of TPS that you can do on layer 2 securely goes up over 1,000. Now, if we take the PeerDAS model as it exists, and we crank up the parameters as far as it seems reasonable, we could actually get to 128 blobs. So we could actually get to the original final target for the number of blobs just by using PeerDAS. And then if we get to 128 blobs, then we can get to something like 10,000 transactions a second. And then if layer 2s do more data compression, we can get to 50,000. But then now the goal actually is to go even higher, right? So the current goal is to get to 512 blobs and then potentially go even higher. So layer 2 scaling, actually pretty simple, right? More blobs, and even more blobs. So this is the scale part, right? I think one other thing that's really important to talk about is the security part of layer 2s, right? So this is probably one of the things that's been the most challenging with the whole layer 2 concept as we've actually seen it play out over the last couple of years, which is basically that in theory, it's possible to make layer 2s that are completely trustless, right? It's possible to make layer 2s that are fully backed by the security of the underlying Ethereum chain. Now, the problem is that a layer 2, and especially a layer 2 that's verifying the EVM, is a pretty huge amount of code. And with a huge amount of code, there's a risk that you have bugs in that code, right? And something as big as an EVM prover inside of a layer 2 verification contract, that's something where verifying that it's secure, it actually takes a lot of effort, right? And so for this reason, layer 2s so far have been pretty scared of giving up their multisigs and their security councils. And so right now we have 3 EVM layer 2s that have gotten to what we call stage 1, which is basically a limited reliance on a security council. And those are Optimism, Arbitrum, and Ink. And I think we can actually be more ambitious and we can actually aim to get to stage 2, right? And the definition of stage 2 is basically a layer 2 that is actually trustless in the sense that the security of the layer 2 would only depend on the code being correct, right? It would depend only on mathematically provable components. Now, you're allowed to have some components that are not mathematically provable, but those components have to have only a limited amount of power, so that if the provable components are all working correctly, they can override the other components, right? So basically, if you imagine a layer 2 with multiple proof systems, then fully trustless proof systems have to take up a more than 50% share, right? So this is where we want to go, right? We want to get to layer 2s that are actually trustless, that are actually provable, that are actually running based on all of these principles that we want layer 2s to run on. Now, the challenge today is, from a usability perspective, optimistic rollups are still quite a bit ahead of the ZK rollups, right? And with ZK rollups, there's two major challenges. One of them is cost, but the cost is very quickly decreasing. The other challenge is that ZK is still a relatively immature technology. It's still, especially at this level of complexity, has quite a high risk that there's some amount of bugs. And so we don't want to fully rely on ZK. But then there's also another problem. The other problem is that with an optimistic rollup, you have to wait 1 week to withdraw, right? If you have an asset inside of an optimistic rollup and you want to withdraw it to layer 1, you have to wait 1 whole week. Now, the way that this works in practice for regular users, right, is that regular users are not going to be actually withdrawing directly, right? Regular users are going to be withdrawing through intents, through market makers, through a cross-protocol ERC 7683, like all of these second layer things, right? And then it's market makers that will be actually doing this like round tripping between layer 1 and layer 2. But the problem is that if these market makers have to wait 1 week every time they withdraw, then this is very capital inefficient for them, right? And if it's capital inefficient for them, then the fees that they're going to charge to regular users trying to move coins between different layer 2s are going to be high, right? And so what we really want is we want layer 2s to go down to having, let's say, maximum 1 hour withdrawal time. And I think in the long run, we can actually get to layer 2s having a 12-second deposit and withdrawal time, and we'll talk a bit about that. But let's get down to 1 hour first, right? So 1 hour basically means no need to, like, none of these sort of challenge response systems, right? Like, optimistic does not work. Basically, you need something where instead of waiting to make sure that nobody says that a particular state root is incorrect, you have proof systems that just tell you that the state root is actually correct, right? So we have to balance these two different concerns, right? Basically, on the one hand, we don't want to rely too much on immature technology yet. On the other hand, we also want to be able to withdraw from layer 2s quickly. And so the design that I think actually does quite a good job of balancing all of these constraints at the same time is this thing that I proposed a couple of days ago, which is a 2 of 3 between optimistic, ZK, and trusted hardware, right? So optimistic, we all know, it's the technology that Optimism and Arbitrum are using, and optimistic rollups, an optimistic proof system, you have to wait 7 days for it to give you an answer. ZK we know, and then trusted execution environments, basically, there's things like SGX, there's TDX, there's a whole bunch of these, right? Basically, they require having trust in a hardware manufacturer, and also they rely on this security assumption that like a particular piece of hardware has not been broken, and breaking into hardware is generally much, much easier than breaking a cryptographic algorithm, right? And so it's a very different kind of security assumption than cryptographic assumptions, but it's one that we can kind of add into the mix, right? And so the goal of this kind of design is basically that we're not leaning on any side too much, right? Basically, trusted execution environments, they can give attestations of correctness immediately, right? And so because 2 out of 3 proof systems, they can give you an answer immediately. In the normal case, you have instant finality, right? In the normal case, a layer 2 submits a block, and then immediately you get a ZK proof of it, and you also get a TEE proof of it. Now, in order for layer 2s to be stage 2, in order for layer 2s to be trustless, you don't want things like TEEs and security councils to actually control the thing, right? If you have a layer 2 that's actually controlled by things like TEEs, then it's not a layer 2 of Ethereum, it's a layer 2 of Intel, right? And so we want but what this architecture does is it limits TEEs to 1/3. And so if the code is working correctly, it doesn't matter if the TEE breaks completely, your funds are still safe, right? And then also at the same time, it still keeps 2 out of 3 in the hands of relatively mature technology. And it's basically making a bet that ZK and TEEs, the risk profiles that they have are sufficiently separate that we're not going to get a ZK breaking and a TEE breaking at the same time, right? And so, or at least being broken by the same attacker, right? The argument is that the things that cause them to be vulnerable are very different from each other. The people that are good at finding those vulnerabilities are very different. And so it's basically as uncorrelated as you can get, right? And so my argument is that if you have this kind of architecture, then it basically actually achieves all of the security properties that we want to the best level that we can today. And at the same time, it will let us be able to natively withdraw from layer 2s within an hour. And I actually think it should be possible to get EVM layer 2s up to something like this within 2025. So that's part 2. Now, part 3, right? Let's talk about fast finalization. So ultimately, I think you should be able to deposit and withdraw from a layer 2 within 12 seconds, right? Layer 2s should be moving closer and closer to just being like Ethereum shards. What is a property that you would expect from an Ethereum shard? You would expect to be able to move things between different Ethereum shards very quickly, right? And so you should be able to expect to move assets between one layer 2 and another layer 2 very quickly, and you should be able to expect to do that natively, right? Why natively? Because, well, if you can do native movement from one layer 2 to another layer 2 within 12 seconds, then you can do things that you cannot do with intent-based protocols, right? With intent-based protocols, you can move ETH from Optimism to Arbitrum. You can move USDC from Optimism to Arbitrum. But you can't move an NFT from Optimism to Arbitrum. Why? Because, well, you can't have a market maker have a second copy of an NFT on every layer 2 so that they can front the liquidity. It's impossible because there's only one copy of that layer 2, right? Or of that NFT. And so can we have cross layer 2 native movements happen within 12 seconds? Can we have everything within the Ethereum world be doable natively within 12 seconds? I think the answer is yes. And I think there is basically 2 things that need to happen for that. One is that proof systems need to become faster, but I actually do not worry too much about this because I think there's a lot of incentive for that to happen already. And actually layer 1 already needs the same thing. But the other piece is basically layer 2 is submitting to layer 1 needs to be much cheaper, right? Today, layer 2 submitting to layer 1, it has a gas cost of over 500,000. And the reason is that basically every time you submit a proof, verifying the proof is very expensive. And so the thing that I think we need to do is we need to create aggregation protocols, right? We need to create protocols where you have many different layer 2s. Each layer 2 submits a proof. And actually, you need to keep this limited to layer 2s. You can combine everything, right? Layer 2s, privacy protocols, account recovery, wallet, ZK email, anything that uses a proof, you can basically have users submit, and then you have one aggregation protocol that takes, say, 100 different proofs, and it replaces them with one single proof of all the proofs. And so you have 100 different protocols where instead of all of them needing to submit 100 separate proofs for 500,000 gas each, they can make much smaller transactions, and you only need one aggregate proof to verify that all of them are correct. This is infrastructure that can be built, and if it can be built, then the submission cost for a layer 2, submitting a state root to a layer 1, can go down to probably below 10,000 gas. And then if you do that, then it actually becomes economically viable for every layer 2 to commit to layer 1 and to have finality in every slot. Right? And so this, I think, is how we can solve that part of the interoperability piece. So I think there's also other interoperability pieces that matter, right? So L1 S-load is really important. L1 S-load basically means that layer 2s will be able to read layer 1. And this basically means that you could use layer 1 as this central store of information. So we can have like key store wallet data on layer 1, you can have Oracle data on layer 1, you can have a lot of different things on layer 1. And then layer 2s become able to just read that data for free without having to pay gas for it. Then we talked about ERC 7683, so users being able to transact with intents. And a lot of this is also just work on the wallet and user experience side, right? So I think like a lot of the time when people talk about problems with Ethereum layer 2s, like a lot of the time the problem isn't even like the base level technology, right? The problem is basically that there's a lot of these inefficiencies in how wallets are designed. And so if you currently are on Arbitrum and you want to move to Optimism, you have to click a bunch of buttons, you have to figure out how to use a bridging protocol. It's very annoying, right? And so what we need for all of that stuff to appear much more native. We need bridging and sending to just look like the same operation to the user. And these are all things that chain-specific addresses, intent, 7683, all of this kind of work actually does, right? So these are kind of the technological directions that I think we need to go in the next probably roughly 1 to 2 years to try to make push layer 2s really to the limit of their potential, right? And I actually feel pretty confident that if we work hard, we can get all of these things done within 2 years, right? I think if we want to be realistic, then if we look at scaling the blobs, we can probably get the first half of this done in 1 year, and then the second half of this done in 1 year. If we look at this 2 of 3, like I actually feel quite confident that we could get this done in 1 year. The thing that will take longer, I think, is doing formal verification, pushing ZK proofs to a much higher level of security, and then eventually in like maybe 3 or 4 years, we can actually get rid of the optimistic, get rid of the TAE, and we can actually have extremely secure zero-knowledge proofs protecting all of our layer 2s and protecting our layer 1 as well, right? But this is something that will just take some more time. And then fast finalization, like this, I think, realistically probably will take 2 years, right? I think realistically this just has much more dependency on zero-knowledge proofs being relatively safe. And I think if we focus on this, then this will already be able to get the layer 1 to layer 2 native bridging time down to 1 hour. And then I think this is like a natural stage 2 of the roadmap, right? Basically bring that bridging time down from 1 hour all the way down to 12 seconds. So if we have all of these things, right, then basically we get to this future where any kind of layer 2, like basically functionally actually does, feel like an Ethereum shard. You actually get the kind of hyperscalable Ethereum experience that we're actually talking about. And at the same time, we're also in a very good position to use a lot of these exact same technologies to start scaling the layer 1 as well, right? And so if we have these things, then I think we can really start to get layer 2 up to a much higher level of security and at the same time a much higher level of scalability. And we can actually say we have an Ethereum ecosystem that actually is ready to serve applications and build things that actually go and benefit like 10 million, 100 million, potentially 1 billion users. And we can feel confident that we're not making any compromises on security, censorship resistance, or permissionlessness while we do that. So thank you.
All right. Thank you, sir. There are some Slido questions that you may want to check out. So this one.
Okay. We have cheap block space now. How do we get the devs to come back and build actual apps? Yeah, I mean, I think, okay, so here's the thing, right? I think this idea that we have cheap block space, for devs to feel confident building serious applications, and like, especially if you think about like large enterprises building institutional applications, you can't just tell them we have cheap block space now. They need to feel confident that there will be cheap block space now and 2 years from now, and if their application goes 100x in number of users, right? Like, and if you think about the like Ethereum L1 right now, today it's cheap. 3 years ago it was expensive. Like, as an app developer, how do you know that Ethereum L1 is not going to become expensive again in 1 year from now, right? Or even if you build an app today based on the assumption that a transaction on layer 1 costs 10 cents, and then your own application succeeds, and then just because of your own application succeeding, it clogs up Ethereum and fees go up to $2, then like that's also a risk for you, right? And so I think we really need to avoid the trap of saying like, oh, everything is cheap, therefore we need to stop worrying about scalability, because it's not true, right? And so, you know, I think basically we need to get both layer 1 scale and layer 2 scale up to the point where, as a large scale application developer, you can actually come in and you can feel confident that transactions will be cheap enough for you, even if a huge number of other applications become extremely successful on top of Ethereum, and the price goes up to 20,000 and everything goes crazy at the same time, right? I think if we just kind of sit back and say things are cheap today, then like that's not good enough, right? Like we have to actually provide that level of guarantee that developers can trust. And I think if we do, then like there are plenty of people that are actually willing to come and build those apps. So that's a big part of the answer. Another part of the answer is that I think as a community, we do need to be more imaginative, and we do need to like actually try harder to think about some of these application layer questions, right? And like, I think, you know, the layer 1 infra stuff and layer 2 infra, it continues to be important, right? But I do think that in terms of like percentage of mind share in our community, the layer 1 and layer 2 stuff probably should decrease somewhat, and the application layer stuff should increase somewhat. And the reason why it's important, I think, is because like, if we as an ecosystem don't lead the way and figure out applications that people want to use and that are actually good for users, then like we'll just still be sitting here in 2028 and we'll still basically have like presidential meme coins and Ponzi's, right? And like that's not a future that I or I think most of us actually wants to see for Ethereum, right? And so I think like active leadership and active thinking of applications both that people want to use and that have business models and that actually make the world better, like I think we can do more in thinking about this. And I mean, I think the higher quality of infrastructure that we have now means that things that we try today can actually be tried at scale, right? Like you can go directly to a much larger group of much more normal users, like you're not just stuck within this like group of 500 enthusiasts, right? And so I think we do need to think about both sides.
Yeah, probably just two more. Okay. So this one.
Could you please elaborate more about stage 2? Why would we need an optimistic way if we're doing ZK? Yes, okay, so the definition of stage 2 is basically a stage 2 rollup is a fully trustless rollup. What does that mean? It means basically that it's a rollup where if the code does not have any bugs, then everything is guaranteed to be correct. Like there isn't some set of humans that can go in and like flip a few switches and steal all of the money, right? So if you're stage 0, then you're basically just a multi-sig, right? The proof system doesn't matter. There's like a group of 8 people, and if they all decide to like click a button, they can take out all of the money, right? In stage 2, it's fully protected by the code. Now, the reason why I suggested we need to have both ZK and OP is because right now, I don't think we're quite at the level where we can afford to fully trust a code, because there's still the risk that code has bugs, right? Now, how do we deal with the risk of bugs? We have 2 different proof systems, and these 2 different proof systems, they have very different risk profiles that are very disconnected from each other, right? Like the situations in which a ZK proof would have bugs and the situations in which an OP proof would have bugs are very different, right? And so That's the argument for having ZK and OP. Now, the argument for bringing in a TEE as well is basically that we want something that, in the normal case, lets you finalize in 1 hour, right? ZK proofs, they can finalize in 1 hour. OP proofs have to wait for 7 days. And so what basically, what this would end up doing in practice is, in normal operation, what happens is, someone proposes a state root, ZK signs off, TE signs off, it's finalized, right? And like the OP thing never actually gets called. The place where the OP thing gets called is if either the ZK has a bug or the TE gets broken. If either one of those exceptional situations happens, then the ZK and the TE will give answers that disagree with each other. If they give answers that disagree with each other, then you have to wait for 7 days for and then the OP proof system acts as a tiebreaker, and it chooses what will hopefully be the correct one of the two.
Right. I think just for the time, let's wrap it up.
Yeah.
And yeah, let's give a round of applause for Sir Vitalik.
Thank you.
And